Right, so for the final video of this day of lectures, I'm going to look at another unit of concentration, and that is molality. Now, this may have been introduced already or will be introduced soon in lab, but I'm going to formally cover it here. And molality and molarity are somewhat related in that they are units of concentration. But molality, and we use this kind of cursive or lowercase m, is moles of solute over kilograms of solvent. Now, this is where the big difference is. Remember that molarity is moles of solute over liters of solution. And sometimes these numbers are the same and sometimes they are not. Now let's just review some other types of concentrations that we've talked about. We looked at mole fraction. So it's the moles of a substance over the total moles that are in the solution. And then we also looked at mass percent, the mass of a solute over the total mass of the whole solution times 100 to put it into percent. Now, why do we have, you know, molality and molarity when they're kind of representing, you know, they're both units of concentration, but it kind of seems redundant. The key thing here is that molarity is temperature dependent because we're dealing with a volume of a substance. Remember, the volume changes with temperature. If all we're dealing with is mass, then with molality, because we're dealing with the mass of solvent, the mass of something doesn't change if you change the volume. And so that's the big purpose, the big difference between having these two different types of somewhat related concentration methods. All right, so let's look at an example. Let's find the molarity, molality, and mole fraction of ammonia. We have 0.485 grams of ammonia and 145 grams of a water solution. The final volume is 144 milliliters. Okay, well, let's find molarity first. We know molarity is moles of solute over liters of solution. We don't have both of those numbers directly, but we can get to them. The moles of solute, we're going to convert to 0.485 grams of ammonia and use the molar mass to get moles of ammonia. And then we can easily find the liters of solution. You can do that in your head. I'm just going to draw it out so that you can see where everything is coming from. Um, but 1 liter is 1,000 milliliters. And so we have 0.144 liters. So now we can plug that into our molarity equation. And that comes out to 0.198 molar. Okay, so let's do mole fraction now. So the mole fraction is the moles of ammonia over the total moles. Now, remember, we got two things here. We have ammonia and we have water. So moles of ammonia plus moles of water? Well, we already know moles of ammonia. Let's do a quick calculation to find out how many moles of water we have. The problem says we have 145 grams of the water. Okay, so we have 1 mole of water, 0.145 kilograms. Wait, why did I say kilograms? Um, it should be, oh yeah, um, 18.02 grams of water. Sorry, I was looking at my wrong notes. And that comes out to 8.0466 moles of water. So now I can toss all of this in here. I already know, as I said, moles of ammonia. I got that from the previous part. And then the total moles on the bottom. All right, so throw that in the calculator. That comes out to 3.53 times 10 to the negative third. And remember, mole fraction is unitless. And now let's calculate the molality. So molality, again, lowercase m, is moles of solute over kilograms of solvent. All right, well, we already have moles of solute. That's the ammonia. And we can quickly get to kilograms of solvent because we have 145 grams of water. And there's 1,000 grams in 1 kilogram. So that's 0.145 kilograms. So we're just plugging it in right to our formula, toss it in the calculator, and that comes out to 0.197 molal. So I guess that's how you say it, molal. Kind of sounds funny, but that's um, instead of molar, it's molal.